Okay, in this video, we'll continue the theorems. Last video, I demonstrated to you the source conversion and the Thevenins and Nortons. In this video, we will demonstrate the superposition theorem. So, theorem number 3. So theorem number 3 is the superposition theorem. So what is superposition? That we decompose the circuit into number of circuits equal to the number of sources in the original circuit, and we solve the circuits, the individual circuits, one by itself, and then combine the results to give us the original results. Let's take an example. Let's have a resistance and a voltage source, a resistance here, and a current source. Let's have 3 ohms here, 6 ohms here, and 90 volts and 6 amps, plus minus. Now, if we look at this circuit, so what we want to determine the current in the 6 ohms resistor using superposition theorem. So if you look at the original circuit here, we have 2 sources. It means we can decompose the circuit into 2 circuits. Each one has only a single source. Let's see how we do that. So this is the original circuit, a resistance 6 ohms, another resistance 3 ohms, and a voltage source plus minus 90 volts. So this will decompose it into 2 circuits. So this plus this. The first circuit (6 ohms, 3 ohms), and it has 90 volts and open circuit here. Why we open circuit? Because we remove the 6 amps current, and when we remove a current source, we make it open circuit, plus minus 90 volts. So this circuit plus the other circuit, 6 ohms, 3 ohms, and we have here 6 amps, and a short circuit here, short circuit. So we have 2 individual circuits because we have 2 sources, 90 volts and 6 amps source. Each circuit must have only a single source. So this circuit has the 90 volt source, the other source is removed, so we make an open circuit because it's a current source. The second circuit has the second Okay, second source, which is 6 amps, and we remove the 90 volts. When we remove a voltage source, we make it a short circuit. So in these two circuits, two individual circuits, we have two currents. One here, we call it I 6 ohms prime, and this I 6 ohms double prime. So I 6 ohms should equal to I 6 ohms prime plus I 6 ohms double prime. So we solve each circuit individually. So I6 prime is equal simply 90 divided by 3 plus 6, because the 3 and the 6 are connected in series, so that will give you 10 amps. The other circuit, we can use the current divider rule to find X. I6 double prime is equal 3 divided by 3 plus 6 times 6 amps. So this will be 3 divided by 18 divided by is 2 amps. Okay, so we finished this by saying that I6 amps 6 ohms is equal to I6 ohms prime. Here is ohms, I6 ohms prime plus I6 ohms double prime. So it will be 10 plus 2. So this will give you 12 amps. This is simple, simply the superposition theorem. Let's take another example. Let's have a current source here, a voltage source here, plus let's take the same resistors, 3 ohms, and here plus minus 90 volts. Let's have here 30 volts, and let's have here again the 6 amps. Okay, so we want to determine the current now, I3 ohms. So determine the current in the 3 ohms resistor using superposition. Okay, so if we look at the circuit, we have 3 sources. It means we should construct 3 independent circuits. The first circuit, 3 ohms, 6 ohms, and the source plus minus 90 volts. And we have here a 30 volts, so we remove that 30 volts source by making a short circuit. And we remove the current source. We remove the current source by making it an open circuit. So this is one circuit. The other circuit, we remove the 90 volt source, we make it a short circuit because it's a voltage source, and we keep the 6 ohms, but we keep the other voltage source plus minus 30 volts, and we remove the current source. And the final circuit, we have both resistors, 3 ohms, 6 ohms, and we make both sources short circuit, and we keep the current source, which is 6 amps. Okay, here 3 ohms and here 6 ohms. Okay, we'll find that. Now we solve individually each circuit. Let's find what is I 3 ohms prime. So I 3 ohms prime is equal to 90 divided by 3 plus 6. So it will give us 10 amps. Okay, and here this is I 3 double prime. Okay, and this I3 on double prime is equal to 30 divided by 3 plus 6 is equal 30 divided by 9 is 30 divided by 9, which is equal to 10 divided by 3 amps. Okay, how about I 3 ohms triple prime? I 3 ohms triple prime is equal to 6 divided by 3 plus 6 times 6 using current divider rule. So it will it will be 6 times 6, 36 divided by 9, I think it's 4 amps. So here using current divider rule. Now let's look at the final answer. What is I 3 ohms? Is equal to, let's look at the original circuit. I 3 ohms is in this direction here. So we must use this direction as positive, the other direction is negative. So I 3 ohms prime in the same direction, so we say plus 10. Plus 10. I 3 double primes, I 3 ohms double prime is in the opposite direction, so it's minus, which is 10 over 3. Okay. The other circuit, it is also in the negative. I3 double prime is in opposite direction, so we say minus here, minus 4. So this will be 3, here 30, minus 10, minus 4 times is 12. So that's 20 minus 12 is 18, I think. 30, 20 minus 12 is 8, right? 8 divided by 3 amps. Okay, 30 minus 10 is 20, minus 12 is 8. Okay, so this is basically superposition theorem. Okay, let's go back to the original, to example number 1. As you see, why we add them here, because both I6 prime, this current and this current are in the same directions, and it is in the same direction as the original circuit current, so it's both plus. This direction is positive, here this direction, I6 ohms is positive, so I6 ohm prime in the same direction should be positive, I6 double prime in the same direction should be positive, so we are correct to add them. While in here, we want the 3 ohms direction, the I3 ohms current in this direction, okay, from left to right. So in the first circuit, it's also from left to right, so we take it positive. And in the second circuit, it is from right to left, so we must take it negative. And in the third circuit, it's from right to left, so we must take it also negative. So 10 minus 10 over 3 minus 4 is equal to 30 minus 10 minus 12 divided by 3. 20 minus 12 is 8 divided by 3. Okay, so we this ends theorems. Okay, now in the second in the video, the next video, I will demonstrate to you the other important topic in DC circuits, which is the methods of analysis. We have two methods of analysis: the mesh analysis and the nodal analysis. So I'll make another video for both methods. Okay, so I'll talk to you later. Okay, thank you.